Hey guys, here's a video to get you all ready for the unit test. So, first two questions, this is basic Math 2 trigonometry. You have three steps. Number one, let's change the color here. Number one, you're going to label your sides. Then after you're done labeling your sides, then you're going to choose sine, cosine, or tangent. And then step three is algebra. So there's no Pythagorean theorem, there's no law of sines, there's good old trigonometry here. So for example, in this one, this is our angle that we're looking at. This is our opposite. This is our hype. This is our adjacent. So hype has information, adjacent is what we want to know. We don't care about the op. So one thing you have to remember is SOHCAHTOA. This is adjacent and hypotenuse, which is going to be cosine. So we'll say cosine of 51 is equal to adjacent over hypotenuse. Then multiply both sides by 93 to get x by itself, and you are all done. Now in this one, here you have adjacent and opposite. So this is tangent. Tangent of 31 is equal to 8 over x. Now the trick on this one is that the x and the tan 31 are going to switch places. And so your answer is x equals 8 over tan 31. Okay, let's take a look at these ones. This is your hype. This is your op. So this is a sine question. Now, we know this is the hype because it's opposite the 90. So just be careful when they're slanty like this. So I'm going to say the sine of x is equal to opposite over hypotenuse, 8 over 12. Now to get x by itself, we have to inverse both sides. And so your answer for this one is x is equal to the inverse sine of 8/12. And you should reduce it, but I won't take points off if you don't. Next question, law of sines. So for this one, you have 34 is across from 8. So the way the law of sines works is this. We're going to say the sine of 34 divided by its opposite side is equal to the sine of 67 divided by its opposite side. So sine of 67 divided by the letter A. Now to get the answer, we're going to cross multiply. And when we cross multiply, we have A times the sine of 34 is equal to 8 times the sine of 67. Now to get this letter A all by itself, we're going to divide out the sine 34, and we have to do it to that side as well, divide by sine 34. That cancels out, and your answer is 8 times the sine of 67 divided by the sine of 34. Okay, reference angle. Reference angle is how much rotation you need to get to the x-axis. Because this is an important one, let me get out of here, and let's just open a new note here and walk through this. So if you have an angle that's right here, then the reference angle is how much more rotation you need to get to the x-axis. So this would be your reference angle. Okay, this is if it's in quadrant 2. So if this is 170 degrees, your reference angle would be 10 degrees, because that's what you need to get to 180. Let's do another example. Let's put this one in the third quadrant. Here, your reference angle is how much rotation you need to get back to the x-axis. Now we want to go to the closest x-axis. You could go to this x-axis, but it's a lot further, so we always rotate to the closest x-axis. So this is your reference angle. So if this is 200 degrees, then this would be 20, because you overshot. This is 180, it's 20 more. So you have to wind back 20 to get to the x-axis the fastest. Let's do one more. Let's suppose you are here in the fourth quadrant. Let's say your angle is 350. Your reference angle is always tucked in between here, your terminal side, and here your x-axis, and so this is 10 degrees. Because to finish this, to get all the way back, that's 360, and so you would need 10 degrees more. So the reference angle is how much more you need to rotate to get to the x-axis. Okay, so let's go back to the actual study guide. Here's one. And do some of these reference angles. 401 degrees. Now 401 degrees, let's actually go back to this one and use some more space. 401 degrees. So 401 degrees. This is 90, 180, 270, 360. What did I say that was? 401. Okay, so 401 degrees. So 401 degrees, this is 360. So 401 is going to be 41 beyond that. And so here, your reference angle is 41 degrees, because that's how much you would have to wind back to get to the x-axis. All right, let's do another one. This one right here, let's do negative 210. So negative 210. So if we do negative 210, let's draw our axes out. So negative rotation is this way. This is negative 180, so I got to keep on going 30 beyond that. Okay, so this is negative 210 degrees. Again, the reference angle is how much you need to rotate to get back to the x-axis, and 30 degrees would take you back to that 180. Okay, so we overshot it by 30 degrees, and 30 degrees will wind us back to that x-axis. Okay, this one right here, question number 5. For this one, we're all about using the reference angle. Let's do the cosine of 148. Now, if I can squeeze this in here, 148 is not quite to 180. In fact, 148 is going to be 32 degrees shy of 180. Okay, so 32 is the reference angle, so we're going to look at this right here. Now let me draw this over on the side. What does 32 look like? All right, this is 32. Now, if you look at this angle right here, and you look at this angle right there, and you look at this height, right? This height right here, this y value, and this y value is going to be exactly the same. Now, if you look at, so the y value is 0.54, so this is going to be 0.54 high. This would also be 0.54 high. Okay, now this is the x value. From here to here, this is 0.84. Now from here to here, this is going to be negative 0.84. Because everything in this quadrant, the sine values, the x values are negative. I mean, the cosine values, the x values are negative. So the answer to this is negative 0.84. Okay, question 6 is using the unit circle. Just sine and cosine are going to be on that one. Sine, cosine, and tangent, there will be no secant, cosecant, cotangent, that kind of stuff. Let's do one of these just for fun. Sine of 5 pi halves. Unit circle, this is 1 pi halves, 2 pi halves, 3 pi halves, 4 pi halves, and this is also the same thing as 5 pi halves. So 5 pi halves is going around the circle and around a bit more. It's asking for the sine value. The sine value is the y value. At that point, the y value is 1. The x value is 0. Cosine of pi over 6, you draw your unit circle. Pi over 6 is 30 degrees. And you can tell right here, it's the x value that's long. That's the square root of 3 over 2. Okay. Again, review your unit circle on this one. Let's do these graphing ones really quick. For these graphing ones, let's see, let me get this all erased first. All right, graphing ones. Here's a process. Number 1, draw the midline first. After you draw the midline, draw a ceiling and a floor based off of the amplitude. And then number 3, deal with your period. Deal with the period of the function. Okay. So right here, midline. Midline is -1. We're going to draw this -1. All right. So that is your midline. All right. Now, the amplitude is 2. So we're going to go 2 above that. That's your ceiling. And then let's go in and do your floor. Your floor is right there. So we got your ceiling, we got your floor. And now, this is a sine wave. Sine waves go like this. This is a negative sine wave, though. So negative sine waves are going to be like that. All right. So we know we're going to start here. We know we're going to do something like that. But we have to consider the period. Now, the period is equal to 2 pi over b. And the b is this number right in there. Okay, so this is 1/2. Okay, you could write this. Let me clear this off so you can see this. I could write this like this, and maybe you can see the 1/2 better this way. 1/2 x. There you go. Now you can see that the b is 1/2. So period is equal to 2 pi over b, which is 2 pi over, again, this is our b, 2 pi over 1/2. That's going to be 4 pi. So the period is 4 pi, so I'm just going to label this 1 pi, 2 pi, 3 pi, and 4 pi. So that means this period is going to happen in 4 pi. So now I'm going to go in here, and we're going to go from this point, we're going to go here in the middle, it hits that, low, high, down, up, up. Okay, and that's it. Okay, that's all I have for now. If you have any questions, come find me before the quiz or test. Good luck, guys.